Hello, my name is METİN ARIDAŞIR. This is 23rd part of explanation of my physics theory, and this is continued part of 22nd video. Remember, here again, this is my plotting of real blackbody radiation graph. From that point, starting point, 90 degree, then like sawtooth shape. This is real blackbody radiation graph, and this is real all of continuous spectrum graphs foundation. And here this is my original graph, and when I connected hill points, this is the roughly blackbody's radiation graph. I have drew that graph, original graph, according to my theory and my formulas for each degree from 90 degree to 0 degree. Wavelength, energy in EV. Now I will go on. Remember, according to my theory, this was the sphere, and this was electron in relocating at a certain VE velocity. And we were counting wave number of, for example, 35 degree, okay? And we find N35 according to my that relation formula 8.611, okay? Now, we will find N, then we will find lambda alpha, then we put in this formula, which I put forth. This is my formula, energy formula, okay? Then we will plot wavelength through the zero, energy through the infinity, then projection, each plot, each wavelength projected each degree, okay? Now we will find in 30 degree wavelength and energy, okay? And we plot here, and we know 1, 2, 3 paces, 4, from this point to 90 degree through the 90 degree point. Okay. But 3 number, wave number, here 30 degree, 8.611. But now, this is decimal number. This is whole number, okay? This is fractional. We eliminate fractional. We only take account this whole number, integer, okay? Then we will put this place, 8. Now we can account. Firstly, wait a moment, lambda alpha. We will account lambda alpha. We find n. Because of that, 1, 2, 3 wave number, it must be 8 or 9 or 10. It must be integer. Okay. Just that time, arriving time, wave number is 3, here 8, but another, it's not 7 or 9, okay. We must say, therefore, here 8, okay. Here 3, here 8, okay. At 35 degree. This is the n, at this degree. We have found n by through accounting computing electron motion form, velocity, and d alpha, wavelength. I'm so sorry, wave velocity. First, we find electron motion forms velocity, relocating velocity. Then we have found wave velocity at 35 degree. Then through this we have found n in 35 degree, 8 wave number. Okay. Now we account lambda n minus delta lambda cosine alpha. Quickly. 0.238 65 multiplied by again cosine alpha 35 degree. What was cosine 35? It was here 0.819.152 equals to minus lambda n 0.3, yes, delta lambda is equal to here lambda n minus delta lambda cosine alpha, or lambda alpha is equal to 0 point, okay, nanometer. Yes, h multiplied by c divided by what? H squared, 64 multiplied by lambda alpha, 0.104509 equal to here. Okay, wait a moment. Yes. Multiplying that, finally 6 point, okay, equal to joule, 1 point, yes, here energy 185.32 eV. Here, for say say 100 eV, 200 eV, 300 eV, 400 eV, okay. At 35 degree, what is the wavelength? Wavelength is 0.10459. Okay, we find wavelength here. (35°). At 35 degree, here, say, this is the point, okay. Then, in same way, for 34 degree, for example, I counted and 34 what? Say, and 34, I found yes, wave number for 34 degree, 8.81. Okay, but again we eliminate this point fraction. Okay, this integer is important, 8, and cosine 34 will change, and wave velocity will change, wave number will change, okay, Yes, here. This is same. This is same. These will change. These are change. Yes. For 34-degree, electron velocity is 102,150.3199 goes on. Okay. And finally, we find this, and 34 degrees 8.81. Okay, but we take account this. Then for 34 degree, 0 point cosine 34 is 0.829 goes on. With this we have found this one. We multiplied and minus etc. Then we will find lambda and delta lambda cosine 34. Okay. Again. For 34, it is 2,150, okay, nanometer. Then we put the figures, and finally energy for 34 will be 189.60 eV. Like this. Yes, approximately here. Okay. So on and so forth. Goes on like that. Okay. For instance, at 32 degree, suddenly we find wave number 9.2. We take into account 9. We have took into account 8 before, but now for 32 degree, we will take into account only 9. And we put 9, and in 32 degree cosine alpha is equal to 0.848048. We will find at that point 2 degree, wave velocity, okay, wavelength, and we will find n through my formula. Then we put here, then we will find lambda alpha, and therefore we put n and we put lambda alpha, okay, in here. We come here, 32 degree, okay, projected. This is wavelength point, this is degree point, okay, as shadow. Then we say this is x lambda alpha, and this is, say, 32 degree. Suddenly like this, go up, then suddenly down, okay. Don't forget this. At the rate of wave number, point energy, touching energy, remember, En alpha equal to hc divided by n squared, okay? And lambda n minus delta lambda cosine alpha, okay, remember? For each wave, point energy will drop. Now, at the rate of squared wave number, or inversely proportional to squared wave number, touching energy of the wave decreases. So, for same distance to travel, same distance, okay. Again, at the rate of squared wave number, inversely proportional to squared wave number, touching energy of the wave decreases. So, for same distance to travel, the waves which are at different wavelengths will have different point energies. For instance, greater wavelength wave slice. This is electron motion form. Remember, okay? Remember, please, relocating electron motion form. The direction narrower, larger, okay? Changing wavelengths, changing wave velocities, changing wave numbers, okay? Again, at the rate of squared wave number, or inversely proportional to squared wave number, touching energy of the wave decreases. So, for same distance to travel, same distance in this sphere, okay, 0.9 nanometer, remember. For instance, for same distance to travel, the waves which are at different wavelengths will have different point energies. For instance, greater wavelength wave slice, of relocating electron motion form will have lesser wave number to arrive same distance, and therefore its points energy will be greater than smaller wavelength slice. For example, here. Think of three-dimensional in motion. Then smaller wavelength slice of same relocating electron motion form which has same frequency. Don't forget this, please. Then for all my empty times approximately in 3 days, I managed to drill with my mind eye this graph, blackbody radiation graph. Starting point here, zigzag, but interesting sawtooth pattern. Then here, from starting point here, but this is roughly blackbody radiation or continuous spectrum appearance, but in reality here, okay? This graph for only 0.9 nanometer, this in the sphere which its radius 0.9 nanometer, and only third normal wavelength, for normal wavelength, only 3 wave number or 14 wave number or 8 wave numbers, okay? So small part for electron motion for this graph with theoretical eye, with my theoretical eye. According to my theory and according to my formulas, this is the real shape. Then, interestingly, I try to find this pattern in nature. Then, astrophysical observation graphs, most of astrophysical observation graphs, galactic blackbody graphs, I saw like this, okay? I advise to look for same pattern on galactic observation data. Yes, I will go on next to tell my theory, my concepts, my formulas wholly. I will try. I will put forth all my theories step by step. I will do that. Good night. See you later.